Vibrations are repetitive motions that most things do. Sometimes it's on purpose and sometimes it's accidental. About the simplest form of vibration is the up and down motion of the end of this slinky when I stretch and release it. Typically, vibrations are repetitive in some way. In the case of this slinky, the bottom of the slinky moves up and down. Each round trip that the end makes is called a cycle. In this video, we'll talk about the simplest up and down slinky vibration. We'll use this motion to define some basic terms and concepts. We'll use these terms and concepts later for more complicated types of vibrations. Here's a picture of a spring that's fixed at its upper end. We can suspend a weight or mass to the bottom of the spring to make things a little more interesting. If I pull down on the mass, the spring stretches as shown in this picture. If I let the mass go, the slinky will try to return to its original position. Usually, the mass will have enough momentum so that it will pass its original position and go higher than that. Eventually, though, the mass will reach its highest point. Now, the mass will start to fall back down and likely pass this original position and come back here. Once it gets back to its lowest position, the mass will bounce up to the top point again, and the cycle will repeat itself. The trip from the bottom position here up to the top position here, and then back to the bottom position is called one cycle of the vibration. The time it takes to go through one cycle of the vibration is called the period of the motion. It's more common to describe vibrations in terms of their frequency rather than their period. Frequency is just the number of cycles completed during the time required to complete those cycles. If time is measured in seconds, the units of frequency are cycles per second, which are called hertz and are abbreviated Hz. I'll use this system for my experiment. I have a spring that's made of a length of slinky with a mass at the bottom of it consisting of some number of washers. The upper end of the spring is fixed here. If I pull down on the bottom of the slinky and then release it, the masses oscillate up and down. I want to find the frequency of this oscillation. I'll use the stopwatch function on my phone's clock to time the oscillation period. It'll be hard to accurately time a single oscillation, so I'll get the time for 10 oscillations. The frequency is the number of oscillations divided by the period of 10 oscillations. Let's do that calculation now. Suppose we have a spring mass system and the time required to complete 10 cycles is measured to be 7.9 seconds. The frequency then is the number of cycles per 7.9 seconds. 10 over 7.9 is about 1.27, and the units are cycles per second. So we calculate that the mass goes through 1.27 cycles every second, which is the same as 1.27 hertz.